Hello everyone, this is your online assignment tutor. In today's video, we will be looking at basic electronics. So we are going to talk about the electronic component symbol. So let's talk about the electronic component symbol. Electronics component symbols, because that is the first thing we need to learn as we go into the topic, because this is a foundation. But let's look at cell. What is the symbol of cell? So when you see something like this is actually a cell. The long terminal here is the positive terminal. The short terminal here is the negative terminal. So this is a cell. This is a cell. Then when you have something like this, let's say about 1 over 2. Let me have something like this. These are plus. These are combination of cells, which is called battery. So the combination of two or more cells are called batteries. Battery. This is a symbol of battery. Then we have another one. This is a switch, or you call it key. This is switch or key. When you see symbol like this in a circuit, it's a switch or key. Then we have this sorry, I didn't draw it well. Sorry, I don't mind my drawing. This is a lamp. It's just one line here and one line here, like a times. So when you see something like this in a circuit, it's known as lamp. Then we do another one. We have this. We have this. Anytime you see something like this in a circuit, it's a symbol of a fuse. Fuse. So let's take another one. This is voltmeter. Voltmeter. Let's take another one. This ammeter. Ammeter. Let's take another one. This is what? Or something like this. When you something like this is a resistor. Resistor. Let's take another one. This is, let's look at this, or this. So with an arrowhead like this, anytime you something like this, is called rheostat. Rheostat. R-H-E-O-S-T-A-T. Rheostat. Let's take another one. When you see something like this, where the terminal is the same length, this terminal here is the same length with this. It's the same length. This is actually a capacitor. This is a capacitor. This is a capacitor. So let's look at this. This is what we call diode. In the course of electronics, you're going to see how the function of this and how it works in a circuit. This diode. Then we have another one. When you with this arrow pointing upward, this is LED. This LED means light emitting diode. Light emitting diode. 13. We have another one. Then this one is coming inside. The arrow is pointing inside. This is called photodiode. 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 We can have other ones. Let's do this. Number 14. Let's do this. This is actually an inductor. An inductor. Then let's do the last one. There are still many, but let's just take these few ones. Like this, something like this. This is Zener diode. Zener diode. Good. Having know this, you can see that these are symbols of electron. We need to know as we are starting up the topic in basic electronics for beginners like us who is starting now. So we need to come to know this. Very, very important. And so going properly into our electronics, we can let's connect our battery. Let's connect our battery to a resistance. To a resistor, sorry. Let's connect our battery to a resistor. This is a positive terminal, this is negative terminal. Of course, conventional current, now note, conventional current flows from the positive terminal of the battery. Let's call it this conventional current high. This is resistor R. Now, conventional current flows from the positive terminal of the battery through the resistor. Then it ends in a negative terminal of the battery. Why electrons? Electrons always flows from the negative terminal to the positive terminal. That is the difference between electron and conventional current. Now listen very carefully. Conventional current flows from the positive terminal of the battery to the what? To the negative terminal. Why electrons flows from the negative terminal to the positive terminal? That is the characteristics of electron, which is actually different from the characteristics of the current. So now there is a voltage drop on this resistance. Now from Ohm's law, voltage drop on this resistance is voltage drop is equal to what? I times R. That is I, the product of I times what? Times R. Yet, so that means that I, which is the current, the current is I, which is equal to V over what? Over R. Now the voltage is measured in what? In volts. Current is measured in amperes. In amperes. Why resistance is measured in what? In this is a symbol of ohms. Now I can write it in full. The volt is equal to this volt. This amperes. This represents amperes. And this one, which is the ohms, which is this symbol, this is ohms. So that is the idea of Ohm's law. So Ohm's law is just giving us the relationship between the voltage, current, and the resistance. And with this formula now, if we have a voltage in a circuit and we are alternating the current and the resistance, we will discover that if from this formula here, if we increase the current, if we increase the current, the resistance will go low. Then the resistance will go low. And if we increase the resistance, the current will go low, because the current is inversely proportional to the resistance. You get it now? It's inversely proportional to the resistor. And let us do a small, let us plot a small graph. Let's say we have our current high and we have our we have our resistance. Let's say we move as, okay, let's say our voltage, let's say our voltage is constant. Let's say our voltage is constant. Let's call our voltage, maybe let's say 12 volts. 12 volts. The voltage is constant, which is 12 volts. And we are alternating the current and resistance. Let's say, for example, we start with a resistance 2 ohms. We move to 3. We move to 4. We move to 6. So corresponding current will now be 12 divided by 2. That is what? 6 amperes. This one is measured in amperes. This one is in ohms. This one is in volt. So 12 divided by 2 will give you 6. 12 divided by 3 will give you 4. 12 divided by 4 will give you 3. 12 divided by 6 will give you 2. You see that as you increase the resistance, the current drops. So if we plot a graph and we have our current here, the amperes, and resistance here, and we want to plot our graph, let's say we have this is 0 origin, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Also, we have 1, 2, 3, 4, 5, 6. So let us plot when the current is 6, the resistance was what? Was 2. When the current is 6, this is here, the resistance was 2. So this is the resistance here. It was 2. So we trace it down here. So we put a dot there. That is the point. Then we look at the graphic. When the current was 4, resistance was 3. When the current was 4, yeah, resistance was 2. We will trace it to the resistance where it was 3, down here. So we put a point here. So let's go again. When the current was 3, resistance was 4. So 3 here, current was 3, resistance was 4. So we have it here. So when the current was 2, resistance was 6. That was current here is 2, and resistance was what? Was 6. So we have it here. So if we look at it critically, you discover that you will have a slowdown curve. A slowdown curve to tell us that current increases as resistance increases, the current reduces. You can see now, that's why we have a curve coming from the top down. downward. So this is the graph of current against resistance. Current against resistance. So that is when you are being asked in exam, they may draw different things, maybe in any exam. When you see a curve like this, and they plot I against R, you should know that this is the behavior of how current and resistance exhibit. That is the behavior they exhibit. I hope that is clear. Good. So another thing we want to talk about is the potential difference. Now, let's come back before we talk about potential difference. Let's come back to this. Before we talk about potential difference and other maybe electromotive force. Let's come back to this. Now, if we look at this critically, we can define current, we can define our voltage, we can define resistance. Now, what is current? What is current? First of all, what is current? Current is the what? Rate of flow. Is the rate of flow of electric charges or electric charge around a circuit. Is the rate of flow of electric charge around a circuit. Or some people use in some textbooks, you see it as it is the movement. It is the rate of drift or rate of drift of electrons in a material. In a material. So if now watch this, if a charge Q flows in a point in t seconds, the electric current, the current I will be equals to Q over T. You get that? It was Q over T. And the implication of that is that the unit of current I is equal to Coulomb per what? Per seconds. That is CS minus 1. Coulomb per seconds. Or you can say just amperes. Just say amperes. This is amperes here. Amperes. Or amperes. Do you see it? Or amperes. So it is Q over T, Coulomb per seconds or amperes. That is that. Now, let's talk about resistance. Let's talk about resistance. Let's talk about what? Resistance. No, when you just like resistance, to resist, it means opposition to a flow. Opposition to a flow. What is now? The question now asks yourself, what is flowing? Then to a flow of current in a circuit. Go to the flow of current in a circuit. Are you getting it now? Now that brings us to, because resistance in a circuit is very, very important. In your house, example of resistance at your TV, your radio, your fridge, your laptops, your phones, all those gadgets you use to that you plug in your fuse that make that make opposite the flow of current, which bring about the voltage. They are called resistance. You get that? They are called what? Resistance. So we are going to look at. Let's look at. We're going to look at. We're going to look at parallel circuit, parallel and series circuit. So we're going to look at series, resistance in series and resistance in parallel. It's very, very important we look into it so that we know how current and voltage flows in those resistance, how they are being connected, how current flows in them. So we are going to look at let's look at series connection. Let's take three resistance for example. So let's look at series. This is series connection. This series connection. So you have your resistance here. Let's call this one R1. You have another resistance here connected in head to head, R2. You have another resistance here connect head to head with the third one. You have what? R3. You get what I'm saying now? Now, one thing you have to know is that the voltage connected across these guys is actually going to be the same because is going to measure the overall current that passes through here. The voltage drop here will be different from the voltage drop here. The voltage drop here will be different from the voltage drop here, but there's an overall voltage. Now, let's take this. There's a voltage here. Let's call that voltage V total. Let's call that voltage V total. Okay, yeah. Let's call that voltage V total. Now there's a current drop here. Let's call it I1. There's a current drop here. Let's call it what? I2. There is a current drop here. Let's call it what? I3. Then we have I total. I total. Now, from Ohm's law, we know that V equals to IR. Is that not so? So it means that V total will be equals to V1 plus V2 plus V3. Therefore, that means that V total will now be I1 R1 plus I2 R2 plus I3 R3. But one thing you have to know, that the statement I said the other time, the current that drops here is equal to the current that drops here. Is equal to the current that drops here, because in series connection, the same current flows through the resistor, the same current. So that by implication, that means that I total is equal to I1 is equal to I2 is equal to I3. So by implication, since they are equal, therefore, that means that V total will now be equal to I total R total is now equals to I1 R1 plus I2 R2 plus I3 R3. So since they are equal, it will now be therefore R total will now be equals to R1 plus R2 plus R3. This is the resistance in series connection. That's what we have here in series connection. In series connection. Now let's now look at parallel connection. Let's look at what? Parallel connection. Now, in parallel connection, you have something like this. Now, listen very carefully. These resistors are in parallel. They are in parallel. These resistors are in parallel. This is what? R1. This R2. This R3. Then you see it now. So there is a voltage here. Let's call it V total. There is a voltage here. And there is a current. The current of this one is I1. The current of this one is I2. The current of this one is what? I3. Are you getting this? But there is an overall current called I total. Are you getting it? So therefore, we have I total. Since different current flows in a parallel connection, you have the current that flows here is different from the current that flows here. It's different from the current that flow here. Therefore, there will be an overall current. That will mean that I total equals what? I1 plus I2 plus what? I3. So therefore, from Ohm's law, I total equals to volt total over R total. Now, another thing you must know about parallel connection is that the voltage drop here, which is V1, is also the voltage drop which is V2, and this also V3. And the beautiful part of it in parallel connection is that their potential difference, which is voltage, they are equal. They are the same. The voltage drop is equal to this one, is equal to this one. So it means V total is equal to what? V1 is equal to V2 is equal to V3. So by implication, if we do this, we will have I total equals to V1 over R1 plus V2 over R2 plus V3 over R3. Since the voltage drop are equal, that means that I total will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Sorry, this one will go I total, sorry. Okay, we didn't replace this one. This one will be V total over R total. So V total over R total. So that's what it becomes, because this high total have to replace with the V total over R total. So we have, since they are equal, this one too will become 1. So this one will become 1 over R total will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So therefore, R total will now be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Or everything raised to power what? Minus 1. Because the inverse of everything is what will give you the total resistance. So this is the resistance in parallel connection. The resistance in parallel connection. Resistance in parallel connection. So there, I will know that we are going to look at potential difference, which we will always call PD. Then we will look at electromotive force, which what we call EMF, electromotive force. Now, what is potential difference? Now, if you look at the flow of current from one end to another end, you discover that is, if you look at it, if you consider like a pipe, let's say we have a pipe in the house, there is always a, 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 a place or the source where the pipe flows, where the water where liquid flow from one end to the other end. That place where the liquid come from is known as a place of higher potential. We call it positive, a place of higher potential. And where the flow of the liquid or the fluid is going, the place is actually ending, is called the place of lower potential. They call it negative terminal. Negative terminal. So when you talk about potential difference, you talk about 2 points. 2 points. You get it? And you talk about a charge being carried between 2 points. The electrical charge between 2 points, the work it will take the charge to move from this point to this point. The work done, it will take a charge to move from this point to this point, is what we call potential difference. So potential difference, which is PD, is the amount of work done in transferring 1 coulomb of electric charge, between 2 points. 1 coulomb of what? Electric charge between 2 points. And that is why it is also measured in what? It is measured in joules per coulomb or volts. It's either you measure it in joules per coulomb or volts. See, volt and joules per coulomb are the same, they are equivalent. This is joules per coulomb. So in the work required in taking a charge from the higher potential to the lower potential, the work in transferring electric charge of 1 coulomb from higher potential to lower potential is called potential difference, PD. It is actually potential difference. And before we go further, you must know this. What are electric cells? You know, when we talk about cell is actually a device used in generating electric current. Those are cells. You remember the symbol we drew the other time? That cell generates electric current. Now let's talk about EMF. What is EMF? Now, anytime you hear the word EMF, something should strike in your mind. You know, that means that there is always a driving force for every flow in a circuit. That driving force is what we call the EMF. So the EMF is an overall voltage. Also, it's an overall voltage. The voltage across the terminal of the circuit, and the voltage in addition to the voltage connected across the cell or battery. So that's why you always say EMF is equal to big V plus small v. The big V is the terminal voltage, which is called terminal potential difference. The small v is the voltage across the internal resistance, of the cell. The voltage across the internal vessel of the cell. The voltage across the terminal of the circuit. This is the terminal voltage. This is the voltage as a result of the internal vessel of the cell. the voltage across the internal resistance, the voltage across the external resistance, the voltage across the internal resistance of the battery, of the circuit, the voltage connected across the internal resistance of the battery, of the cell. Now, let me say it again. This is the voltage connected across the external resistance of the circuit. This is the voltage connected across the internal resistance of the battery. That is what we call EMF. EMF, another definition you can give to EMF, let me write it here. EMF is the total energy, per coulomb of charge obtained from the cell, from the what? From the circuit. From the circuit. Is the total energy per coulomb obtained from the circuit. And that's why it is measured in also in volt, because it's in volt. It's measured in volt, of course, or joules per coulomb. So therefore, you have your EMF equals to big V plus small v. You get what I'm saying now? Is big V plus what? Plus small v. So let us look at it from the point of this. Let's say we have a circuit. This is the resistance of that circuit. This is the resistance, and it is connected to a cell. It's connected to a cell. Of course, it's connected to a cell. There is a driving force for this cell. The driving force for this cell is there's an EMF driving this cell, and it has a what? Internal resistance. Of course, there's an internal resistance R in this battery. A current flows through the battery around the circuit. Then across this resistance, there is a voltage, there is a terminal voltage. There's a terminal voltage. Let's call it big V. There's a terminal voltage. And there is also a voltage here. That voltage, let's call it small v. There is a voltage here. Let's call it small v. So what we now have now is that we have EMF equals to big V plus small v. So the big V is the current across the big R, plus the small v, which is the voltage across the internal resistance, is the current across the internal resistance. So therefore, our EMF, this is EMF, our EMF will now be equals to I bracket R plus small r. Hope you're seeing it now. That is our formula for finding EMF. Do you see it now? That's our formula for finding. That's the formula for finding the EMF. Another thing that you have to know again is what we call when you are being asked, find the lost voltage. Now, you don't need to struggle to be saying, how can I get the lost voltage? The lost voltage is just the voltage across the internal resistor, because that is where the current is being delivered, and that is where when the current is being delivered, the battery begin to lose the force, the EMF. It begin to lose the driving force to give current to the circuit. Now, take for example, if you connect a lamp here, let's say you connect a lamp here. As time goes on, as this battery is being used, what happens? the driving force to lighten up this lamp become dimmer. The lighting become dimmer. Why? Because there's a loss voltage. So the loss voltage is equal to I multiplied by small r. So is the current multiplied by the internal resistance of the battery. Internal resistance of the battery. You have to take note, because it can come out in theory. As you calculate the loss voltage, you need to get it right. You understand what I'm saying now? So let's look at should we look at a problem for we to solve? Okay, let's still talk about something very important. Something very, 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 very important. Okay. Okay, let's look at some questions. Let's look at some questions. We'll just take a question. Say, find the total resistance in the figure, in the circuit arrangement below. In the circuit arrangement below. Let's find the total resistance. Let me draw it. Let me draw it. So we have this. You have this. You have this. Then you have another one here. Yes. So this is 3 ohms, 3 ohms, 2 ohms, 2 ohms, 3 ohms, 2 ohms. So they are asking us to find the total resistance. Can you find it? Well, we are going to solve it together. We'll find the total resistance. Now, when you see a question like this, you don't need to panic. It's very simple. What I always advise students is that when you see a question like this, don't start here. You'll be confused. Start from the back. You start from the back and you start breaking the circuit little by little. Now, when you want to solve something like this, look at it. Start from the back. What do you have here? You have 2 and 3. You discover that when the current flow like this, there's no division here. So it means that 2 and 3 are in series. So you just come here and say 2 ohms plus 3 ohms. You have 5 ohms. You have gotten that one. So the whole of this is 5 ohms. And that 5 ohms is in parallel with 2 ohms. You see now, the whole 5 ohms is in parallel with 2 ohms. So 5 ohms is in parallel with what? 2 ohms. So you quickly find it. So you have 1 over 5 plus 1 over 2. That will give you 2 plus 5 over 10. That is 7 over what? Over 10. So because of you have to, it always is inverse. That will now be 10 over what? 7 ohms. So we'll come back to the question. The whole of this, the whole of this is in series with this. You see now, the whole of this is in series with this guy, with these 2 ohms. So you have to say 10 over 7 plus 2 ohms. You see now, that will give you, find the SCM, that is 14 plus 10, that is 24 over 7. So 24 over 7 is in parallel with 3 ohms. So 24 over 7 is in parallel with what? 3 ohms. So we are going to solve it parallel. So you have 1 over r equals to 1 over 24 over 7 plus 1 over 3. You don't need to panic. you just say 3 times 1, 3, plus 24 over 7 times 1, that is 24 over 7. So you have SCM of this is what? So it will be 24 over 7 times 3. So that will now be 1 over R equals to 7 times 3, that is 21. 21 plus 24, that is what? 45 over 7 divided by 24 times 3, that is what? 72 over 7. You see now, since it's inverse, so you have to do R equals to 72 or R equals to, you turn it. You put this one up, put this one down. That will now be what? 72 over 7 divided by 45 over 7. So if you do it, you have 72 over 7 times 7 over 45. So 7 here 1, 7 here 1. So you have 3 here 15, 3 here 24, 3 here 5, 3 here 8. You have 8 over 5. So the whole of this, 8 over 8, the whole of this place is 8 over 5. It's now in series with 3. So therefore, R total is now equal to 8 over 5 plus 3. So you have 5 here 5, 1 times 8, that is 8 plus 5 here 1, 5 times 3, that is 15. So you have R total equals to what? 23 over what? Over 5 ohms. 23 over 5 ohms. So that is the total resistance of this circuit. Total resistance of this circuit. So that will bring us to the end of this basic electronics for beginners, and we are going to continue in the basic electronics for beginners part 2. That's why it's good for you to subscribe to this channel, so that when I drop that video, you will be the first person to see it. Please kindly subscribe to this YouTube channel. Please just click the like button, share it to physics student, share it to the electronics student. Let them benefit from this knowledge. Please share the video, like this video, subscribe to it. Please kindly subscribe to the YouTube channel. Kindly subscribe. Just click the subscribe button and let's grow this community together. Thank you and have a wonderful day. Bye bye.